Here's a situation where we're rolling dice and we're winning money depending on what the die outcomes are. And you can read the details here of the situation. But here's a distribution that the person can experience and the chance of these outcomes. So the person can win $20, $10, $5, or lose $10. So here's a question. If a person plays this game 15 times, what is the expected number of times the person will win $20? Well, again, you'll notice that we're sampling more than once. We're sampling 15 times. And you kind of have to experience a little bit. What is it that the question really wants to know? How often you're going to win those $20 if you played 15 times? Or what's expected, the average? So what kind of question is this and where does it belong? You'll notice we're counting wins. So we're counting, so it's a sampling distribution of counts of some type. Is it geometric or is it binomial? Well, this is not asking anything about the first win, when you experience that. This is actually saying, what is the expected number of wins in those 15 attempts? It doesn't say when those wins will happen, just that you'll win sometime, those $20. So this reeks of binomial. If that's the case, what we really want is the expected value of the binomial. So if that's the case, how do you calculate the expected value of a binomial? Let's go back to your map. So what's happened is that we've sampling from a discrete distribution. The question is about the number of successes, or the expected number of successes. So I know it's binomial. I come over here, and for a binomial distribution, the expected value is the number of attempts, the number of observations times the probability of success. So what is success here? So this is actually an important part, and you should do this for every problem. Success is winning $20. In other words, you should clearly define what success is in actuality. What's the probability of success? In this case, the probability of success is 0.1667, approximately. What's my sample size? In this case, 15. So, if I want to know the expected value, it's just going to be 50, the probability of success, which is 2.5. So the person's expecting to win $20 about 2.5 times. Now, don't get this confused with this distribution, the binomial, with this distribution. What is the distribution that we're dealing with now? Now we identified this as being binomial. So if I go to my GeoGebra applet, I'll select, again, binomial from the choices, change the sample size, 15, the probability of success, and this is the distribution we're dealing with. So again, this is the question of the scenario that I was drawing from, but really from this scenario, all I care now is winning $20. That's all I care about. What about the rest of these? These are all failures. All I care about is now, that's my target, that's the event I want. Now, I create a scenario where I'm sampling 15 times, and all I want to do is count how many times I win the $20. This says I have in 15 attempts, on average, I won 2.5 times. Again, somewhere between 2 times and 3 times in the most likely scenario. When I come over here, sure enough, here is winning $20 twice. Here's winning $20 3 times. You can see these are the most likely, the highest peaks here for this distribution. Here again, the chance of winning twice is 27%, a little more. Chance of winning 3 times the $20 is 23, almost 24%.